Thanks, Bob. And good afternoon, everyone. I want to thank Composite before I start. So today, you heard a lot about ROI, actually. So this presentation, a lot of the information that you received earlier is very valuable in terms of what ROI and how to achieve our ROI through data virtualization. So maybe I'll take a little different angle and talk about performance-based ROI. The exchange is huge in terms of multiple markets. We support over 14 markets. We basically have different products. We also have a technologies company which sells solutions and shared services. We're in the regulation business, compliance business, risk management business. So a lot of people probably don't know this about the New York Stock Exchange. So we deal with a lot of volume of data. Just to give you an example, on an average day, we deal anywhere from 1.5 to 2 terabytes of data a day. That's our footprint. And on a peak day, that equates into about 8 billion transactions per day. So today I'm going to talk to you more about not necessarily the reference integration story, because a lot of people have mentioned it. I'm going to talk about how do we deal with transactional data and how do we keep data in place, because obviously it's not practical for us to move it around. We have many sophisticated ETL capabilities, but we do some clever things in terms of integration. So I'll mention some of that, and that's really part of our ROI. It's part of the value. So this is just sort of a background in terms of the volume. Today I look at my BlackBerry, and every day I get a market share report. And it's interesting because this market share report now has to cover, like I said, NYSE Classic, NYSE Arca, NYSE Options, Smart Pool, NYSE Life, and so forth and so forth. And that's in total is about 14 different markets, and there's a lot of transactional. And executive management and outside world is interested about what kind of market share the New York Stock NYSE Euronext does. In order to get those types of numbers, it's pretty difficult. So even this BlackBerry notification that I get every day is still got specific buckets for each market. And what we want to do is we want to move forward. We want to basically be visionary, future thinking about how do we integrate this information, how do we get information to the executive, to our customers. So a lot of the stuff that we're doing really is about dealing with mass amounts of data and basically coming up with standards and how do we adapt, because the exchange's vision is really to continue moving forward in terms of being kind of the forerunner in terms of buying exchanges and basically providing added value services like market data feed, for example, super feed. So there's a lot of stuff that's going on. So background, Bob mentioned, my background is really head of enterprise data architecture for NYSE Euronext. I report right into the chief data officer, just to give you sort of an organizational perspective. We take that very seriously at the exchange. Data management is a huge cost to the firm. So obviously we want to do a very good job in a reference architecture. Ted mentioned that nice slide about shared data services. We're definitely about building global data services, shared data services, coming up with common infrastructure, computing, provisioning computing infrastructure, all the things that you're hearing now, we're starting to do. And we're looking at different sort of areas within that, and we have different centers of excellence around each one of those areas, and then we sort of have an architectural council that sits over that, and we have a data management or sort of data governance council that eventually is going to sit on top of that. We don't have the data governance yet, but we're moving towards that, so we know that's all part of the practice. My background has been in a financial services space. That's all I've done in terms of data management within many top-tier companies. I founded a company called Xperia, which really focuses on high performance, and that's the thing I enjoy about this part of the job, is that I combine solutions and innovative patterns to solve very complex transactional data problems. Team responsibilities, I have a team that I'm running in New York, and I've got folks also in Chicago and in UK. Basically, we focus on all these various verticals within the IT domain. Business intelligence is important to us. We're very immature, I have to say. We're not, our users like to basically see the physical model. They want to develop SQL and execute SQL through pass-through query tools. We're trying to move away from that. When you have that much transactional data, you cannot basically go down that path, because one bad query actually impacts everyone. So we're sort of moving now, taking a step back and saying, how do we basically provide information capabilities, better integration capabilities to end users, so become more, business intelligence aware. Common data services, absolutely. We do a lot of work with our customers being either internal or external. We are now moving quickly towards building data services. A lot of the stuff that we do is very complex. We have a whole grid environment, as you see on the bottom, which really where we process most of our transactional data. For example, one big example that we do every day is basically market reconstruction. You know, to do compliance and regulation, you absolutely don't want to do market reconstruction out of the database. You have to create all that data point integration right outside. You have to almost create your book and your depth right as part of your ETL process, and then just put it into your data warehouse and make that accessible through basic either SQL or BI tools. Data architecture is key. I mentioned something about, you know, one of the business use cases, which is the market reconstruction, but data architecture is absolutely a must if you really want to use data virtualization. They go hand in hand. Data virtualization is about joining information. Even if you use it just for a single instance, even within an instance, whether it's an Oracle or a DB2 or whatever you use, you still have complex relationships sometimes you have to resolve, and you still need to know that, you know, primary and foreign key relationships actually are valid, and a lot of thought process needs to go into that as you start working with sourcing the upstream systems. Coming up with a common business nomenclature is important because, you know, our world is huge. We have many different acquisitions and mergers that have happened over time. Everyone's got their own style, their own naming conventions. We're multinational companies with different languages. There's different cultures. So we need to come up with sort of even a virtual data dictionary, if you will, that one that caters to the French folks, one that caters to the UK and the US. So we're actually moving from all different directions. Data access integration. A lot of people talk about data architecture, and they talk about ETL, and they talk about all these great things that you need to do to manage data. But I think one big area that's always missed is data access architecture, and that's where Composite is sort of kind of beginning to fulfill that particular data point or technology as part of our stack in our reference architecture. We attempted, by the way, to do a lot of this data access ourselves. We have very innovative technology folks, smart people. Obviously, to deal with that much volume, you need to sort of do heavy-duty programming. And we tried to do some of this middle-tier data access middleware, and it's pretty complex. As a matter of fact, if you notice in the industry, you see a lot of vendors out there that provide ETL capabilities. You see a lot of vendors out there that provide BI solutions. They're very predictable because, you know, you have clear mapping. You pretty much have sort of a finite number of predictable things or events or functions that you perform. In the world of data virtualization, it's very difficult to sort of guess in terms of how your data sort of aligns. You talked about data quality, or how much volume you're dealing with, or the types of distribution that you have in your environment. So there's a lot of unpredictable things, which makes data access integration much more complex. And there's also the organizational culture and politics that goes along with that. Data warehousing, we're a big data warehousing shop, obviously. We use many different technologies, and I'll point some of them out later in terms of what we evaluated, how we evaluated Composite, and what we're planning to do. And then ETL and ELT design architecture is really key. ELT is big, especially now with the whole MPP space. We can leverage the parallel capabilities of these technologies so we can reuse the database from many different means. So I mentioned a lot of our complexity really comes about from mergers and acquisitions. In the last 5 years, we've grew so much. Our market share today, just on the U.S. market, is about 28% in the equity market. We were losing market share. We're regaining market share because we're making the right acquisitions in terms of the various types of products that we support. We support all products: equities, options, derivatives, swaps, bonds, convertibles, you name it. We're involved in that type of business now. Smart pools, so dark pools, everything that you can imagine in terms of complex trading environments we have. The other thing that makes it really difficult for us, obviously, is the amount of data that we need to keep online, because we're self-regulated. Obviously, we need to make sure that we have a fair market. That's the whole point of an exchange. So the market surveillance algorithms that have to run every day are extremely complex. They're scanning everything. They're looking for patterns for what happened yesterday and comparing them to patterns that have been happening over 3 months. We're now sort of being kind of more integrated with FINRA, as FINRA has taken over some of those responsibilities for regulation. SEC, FINRA, and NYSE and NASDAQ are really spearheading a lot of the things that are going on in the market regulation space, especially after the flash crash and all the things that you've been hearing. So there's been some, shakeups in terms of technology and the requirements, the stringent requirements that are necessary and needed to get this right and to protect ultimately the customers that are outside. Multiple lines of businesses. We just give you a flavor of some of the different areas that we support. And we try to do this, again, smart, because when we have, for example, the NYSE Classic, we produce about 2.5 billion transactions per day, which is the big board, basically. We don't want to be moving that data around. We want to basically be able to support the same set of functionalities if you're doing capacity planning for NYSE Life and capacity planning for NYSE Classic. You want to basically be able to virtualize that, obviously. So, we have smarts in our data architecture where we need to aggregate, we'll aggregate, but most cases we want to get at the transactional level detail when we can in place. Research is a key part of the business because they're always fine-tuning their fees and commissions and models in terms of how the business is going to make money. Member administration is important to the people that do the trading, the specialists and market makers. And all the folks that are basically the agents that interact with the trading venues. Listings, basically, those are the issues, the products that are being traded. So there's a lot of reference data in that space. Finance wants to see the numbers. They want to see volumes. They want to see revenue. They want to see it across the board. It's very hard. Again, this report today, we're not able to do that. There's some even cultural challenges and legal challenges in doing that. Getting information from Europe or from France over to New York, there's some legal ramifications. So we have to also take that into account in terms of our data virtualization model. Web systems and communication, obviously, NYSE is a big brand. We have to do a good job of getting information, very, very useful information in a timely fashion from an external facing perspective. I mentioned that about the daily volumes. To give you an idea, on average, pretty much NYSE Classic 1.5. On the day that we had the flash crash, we did 4 billion transactions. So that gives you the elasticity of the architecture. It has to be there. When we design our systems, we always try to design systems that are at least 2 times greater than what we have today. In the case of the flash crash, we didn't break. We didn't have any outages because we designed it properly. And that was one of the buckets I said earlier about capacity planning. We're always calibrating. We're always identifying the throughput requirements and the database requirements and the operational requirements every day. Because we cannot, absolutely, the exchange cannot come down. You don't see in the news that the New York Stock Exchange even goes down for a minute. We have multiple database systems, as you can see. We're starting to sort of grasp MPP and appliances. 4 years ago, if you came to me as a data architect, I would basically say, no way, I would never use an appliance. It's too proprietary. But we realized that with the kind of mass that we're using and the push of appliances integrating with third-party tools and the standards around SQL interfaces, it's really not so bad. The number of moving parts are being reduced. So we're leveraging the MPP systems. We have in-house Netezza, for example, and we also have Greenplum. But we're making big use of these technologies because we're trying to spend less time on performance optimization, which is what a traditional data architecture database group does, and more time on business processes and integration and ETL-like type of functionality. Replication is fine when you talk about master reference data, and that's very valid. In our case, it is valid because a lot of our trading engines will integrate directly with those ODSs, so we don't want reports to run against them, so we will replicate. So, we have this whole prescription of what we do and when we do it, and part of that is based on the SLAs all the way upstream to the matching engine. So we make those decisions. We say, this is the right technology. This is the use case that we need to use it for. Replication is not valid for transactional data. We don't move it around. So, knowing that in advance, as we start to kind of collaborate with all the leads from all these various areas of the business, we identify the common intersections of all our transactional systems. And we ensure that as part of the standardization that we focus on those, if you will, primary and foreign keys across all federations. And not so much worry about the details of what goes into an option and the details of what goes into equity instruments, but more on the fact that a security or an ISIN or whatever, those common pieces of information have to exist in all these systems. So that's the picture. It's borrowed it from Composite, thank you. But it kind of looks pretty familiar to a lot of organizations, and this is clearly still, we're in some of this state and we're starting to unwind out of this. But the key areas here is that complexity is extreme. Volume and data complexity. We probably have over 4,000 different data elements, right? That's pretty complex with very sophisticated relationships. And if you look at the history of how exchanges sort of, or trading or matching engines got created, the whole notion was about ultra-low latency. So the design was not to cater to the reporting world or the business users. It was more to cater to small size messages and network traffic and fast, ultra-low latency speed. So that's really a problem for a data architect. Certainly been a problem for me. So how do we unwind this? For example, Archipelago does some really sophisticated stuff in encoding their data. Encoding the data is a form of compression. A lot of software companies do it. We do it too in our own way. In order for a user to understand, what type of order it is, good till cancel, all sorts of stuff, you have to decode the information. Writing that in SQL is not so easy. So you can't really implement BI solutions on top of that. So just to give you the kind of complexity. So now we look for opportunities to leverage things like composite and data virtualization, where we can abstract some of that. Even if we're not federating, there's a lot of value in abstracting the complexity of the data. Completeness and latency kind of go a little bit together in terms of the reference data story. These operational data stores are updated constantly. We need a mechanism that allows us to sort of augment the transactional data. We do have end-of-day processes, typically like most organizations. We have intraday processes in terms of pushing the data from an ETL perspective. But now we're looking towards more streaming. How do we get this data from the operational data stores into the data warehouse where the SLAs require that? Locality, we're all over the world. This is it's an old picture, but it's still very relevant. When I started with the exchange, which was about 6 years ago, I basically put this picture together and I said this acronym called TORCA. They had complex data models. They used files for market surveillance. Every single programmer had to sort of reverse engineer the business rules and understand the complexity of the business. I said, that's kind of insane. There's a lot of cost in that. Part of ROI is reducing your footprint for amount of knowledge transfer that's required to get the business right. So I said, why don't we just come up with TORCA, which is really the main entities. No matter what exchange you have, no matter what type of trading venue we're going to buy, there's always trades and orders and reports of the sides, if you will. And there's always tick data, which is the quotes, and there's some administrative messages that are going back and forth. That's pretty typical. So let's come up with this model, and then let's start to figure out how to apply this across to the various venues. And the vision here is really, and this is what we're building out, is to build a corporate information factory, which is what the CIF stands for. And this is in a virtual sense. So these different data sets, consolidated trades, and the audit trail, which probably you heard of if you're in this business, and the orders database information, and the DLE, which is coming from the NYSE Classic, which is the display book where electronically the matching happens. All these complex data systems are storing information in their own way, but we are focused more on the optimization of how to get the data into those systems and then making sure that the common data points, again, are standardized and consistent across all the models. And then now we're starting to focus in the middle here where we have the BI solutions inside of this, where we have some ELT capabilities inside of that, or we have data virtualization capabilities inside of that. So we're building kind of a toolkit, if you will. And then the bottom is kind of your views, your composite, how people want to see the data. One thing that's important, I mentioned 4,000 attributes, probably more if I actually go and do an inventory of all the different markets. You cannot present that from a BI solution or even from a composite solution or anybody to make it really usable. So it's not information. So you have to create subject areas. You got to really focus on, you got to understand the business. You have to work hand in hand with business analysts who are technical. And that's what we started kind of incorporating into our organization. Hiring people who understand the business, who understand financial services, who are also technical, that we can train and they can become data architects within our organization, and they could liaise with the end users and the business communities. And we're doing that, and we find that's been a successful formula. As a matter of fact, it's been so successful that they stole 3 of those guys from my group, and they're part of the actual market regulation group now because they're good at what they do. So this is important for the bottom tier, where they're really kind of doing the information architecture, and they're basically making it more simple to access this information. And then you can imagine that middle tier now starts to evolve with the data services tier. So it really becomes services oriented. So we're very junior when it comes to composite. I'm not going to say that we're experts, but we really are testing it, and we're focusing on performance is our problem. So we're seeing what we can do and working collaboratively with composite. They've been very good. Their engineering staff is excellent. We've given them some ideas, and they've come back. And we're evolving. Hopefully, we're going to help them evolve their product and help us at the same time. In our evaluation, we basically pushed some complex use cases. We didn't go after the traditional use cases because we know we can deal with them in different ways, in terms of like smaller, like finance type of models, or basic metrics aggregation. But we went after things like where we know we have certain order information here, we've got certain tick data here, and how do we basically align some of that data? And the performance are challenging no matter what software technology you have. So that was one of the key things that we put into our sort of evaluation plan. So we came up with a checklist. I'll show you in the next slide some of the bullet points in terms of technology objectives. We started with a small team because obviously I think small teams are more agile, more nimble. You have better chemistry, and you're sort of in sync in terms of what needs to get done. So we had 3 and then part-time person, so that's why I say 3 to 4 that actually did the evaluation. We also had the help of Michael D'Angelo, who was he was great in the whole process. So we were, again, new to composite. We didn't know all the various capabilities that the product can give us. We compared, obviously we always, as part of a reference architecture, you basically have a matrix and you compare, where this particular problem should fit. So we're always looking at BI, ETL replication, and federation in combination. A lot of BI tools have federation built into them. We've looked at them too. We believe that that's really tightly coupling if we go down that road. So instead, we want to have more of a connector-based technology where it's standard, it's generic, and then users can choose whatever BI solution they want. So we don't want to lock in. So we decided against that. Obviously, the goals are important to the ROI, so reuse, agility. A lot of this has been discussed. Reducing the code, the programming footprint, third-party integration, so we can keep moving in licensing. We can reduce a lot of the licensing if we do things right. There are so many different technologies at the exchange. We have, from a database perspective, we have SQL Server, we have OneTick, we have Times10, we have KDB, we have Oracle, we have different variations of Oracle, we have Netezza, we have Greenplum, we have MySQL. And I can go on, and there's been custom solutions too. So it's complex. I mean, how many different drivers do I have to deploy to a desktop phone to do federation? How about versioning of those drivers? Somebody, Oracle comes out with a new release, now I have to deploy a new driver. I mean, there's a lot of value in even just that abstraction and reducing the footprint of your code base. And obviously licensing comes along with that. Short-term business value. The business is really interested in the end about productivity and be able to adapt to all the changes around them. So data availability is key to that. Simplifying access to the data. We get users who know nothing about the European markets, but they want to do volume market share reporting. So we should have sort of a common business semantical layer that gives them what they need from a volume reporting perspective. They shouldn't have to worry that the systems out there are using SQL Server or other technologies. Identify pilot project. We decided that, the best place to start is let's go after our transactional data. We'll start small, but we'll go after a large section of the data. And we focused on 2 areas, capacity planning, which I talked about earlier, which is all about optimizing our business. And we did a little bit of work on the regulatory space. And the idea is that we would drop these use cases, we would get some sort of confirmation from the business in terms of are these actually valuable to you if we are implementing them, and the success criteria around them, and we try to do this in a 4 to 6 week time frame, with the training obviously included. So the checklist really standards based. Yes, we are all about too many different variables, so we need standards. Metadata driven, very key. We want to put the power in the business analyst's hand, a technical business analyst. We don't want to have a long development cycle where you need IT always to generate reports. We don't want that hand-holding. I'd rather have the IT folks focus on integration and volume, dealing with the big challenges of moving data around. Support multiple platforms. Tools that increase productivity. Composite comes with the designer tool, so it's perfect from a data architecture perspective. People are very familiar with mapping and modeling using Irwin-like type of technology, so extending that capability makes a lot of sense. We also have a lot of programmers in our group that build common services, so an IDE like an Eclipse makes sense, so those technologies come as part of the composite, and we like that. Flexible security. Because we have so many different databases and we don't have a single sign-on right now, and that's very difficult for many different reasons, we need to figure out a way to move faster so people have different logins and different passwords. We want to push some of that security into the data virtualization tier. And we also want to have accountability. We want to know what people are doing. So we want to centralize all the metadata. That becomes operational metadata for us. It becomes a way to fine-tune our architecture. Scaling. Adding nodes is important. We're very grid-oriented in the way we think. We don't want to basically build monolithic systems. We want to build very horizontally scalable systems, but we also think about vertically partitioning our data. So we are like three-dimensional data architecture, if you will. So scaling is important. So the software that we choose has to be able to scale. Data caching is key as part of the reference information that we may want to put into it. Monitoring is also important from a timely perspective, so we are proactive, not reactive, in terms of outages and quality of service. Intelligent query engine, we want smarts. We don't just want, here, suck out the data from here and suck out the data from here and then put it in memory. We know that's going to blow up in our world. And we want to have some multi-pass capabilities. Well, semi-join does that in Composite. We like that feature. And we want to continue sort of to see Composite evolve with some of those optimizations. Hopefully we'll continue to work together on some of that in terms of requirements. Minimum impact on performance. We don't want to add too much latency unless it's a very complex federation. If we're accessing a single data store, we expect the result to almost be equivalent. And actually, we may even see improvement because now with the Composite middle tier, you can implement some connection pooling capabilities, so which gives you some value, where now you have custom applications that have different methods for accessing data. Now you've got consistent methods that are tuned and optimized with connection pooling that you can actually see increase of improvements even without federation at all. Cost allocation, once you record everything, you can start to figure out, how people are using the system and eventually charge back if you need to do that. Impact analysis, schemas change a lot. Our business changes so much that we introduce new ways to make money. We create new business events. Those events translate into new transactions. Our data model has to support that. We probably have maybe on the NYSE Classic matching engine, maybe about every 2 weeks we have changes. That's not common in a lot of organizations, but it is common in ours, and we live with that. We live with that change, and we have to architect around it. Usage, building blocks. I'm a big framework person. I believe in you build from the ground up, start with your data, start with your computing environment, and just kind of build these common services and then integrate these services and then find the right technologies where you don't have to build that you can leverage, and then make sure that everything from an interoperability, everything sort of fits. And version control. So just give you some samples of some of the evaluation use cases that we did. One of the use cases that we have is, we have expensive technologies, but they do their job. They're very fast. And these technologies, we have certain amounts of data that's relevant and other data that might not be as relevant and is sitting in different environments. We want to union that data. We want it to look like it sits in one single place. So as part of the evaluation, we did vertical partitioning using federation. It doesn't come out of the box, but with the help of Michael, we were able to build custom procedure with the deployment of a business calendar to each one of these databases that allowed us to do a semi-join against this union and do pruning of federation. So by inspecting the trade date that comes to the query, we're able to access data very quickly without having to move it. So we're aligning the data this way, kind of vertically. Summarization, so there are some key places in our ETL process where as we're streaming data, we're capturing key statistics about the environment, and then we're storing that. And users have a starting point from a business intelligence perspective. And we can start there and then navigate down to the actual transaction level detail. In other cases where we need to recreate or use different filtering strategies, we're using MPP systems for those types of aggregate type of reporting. Another key is the hub and spoke using master reference data. So, We have many dimensions. In this case, the R hub happens to be, it's the reverse, it's the transactional data, and the spokes are all the various reference data systems, corporate actions, member administration, listings administration, and we need different data from different systems. So we bring that data, and our attempt now is to start to kind of building virtual views of those systems and bringing it in real time. So this is a very simplified model, but the goal really for us is integration, standardization, and simplification. So applications, we want to have uniform connectors, right? And JDBC and ODBC, pretty much most of our applications either use one or the other. Obviously, there's a whole web services or web-based paradigm, but this is more of the thick client, even some thin client approach. Composite sits in the middle as the integration server. The metadata repository provides all the mappings, all the useful information, allows us to sort of evolve very quickly, and we build federated views, but very granular subject areas specific to solving specific business problems, not try to map everything. And the bullet points here is really about reducing data mart proliferation, obviously simplifying the deployment of the software, because we have so many tools and technologies, and versioning of those tools and technologies. Centralized security, data services tier is where we want to go, and we're starting to build those out, and caching where we need to. Here are some of the test cases in terms of what we tried. We did integrate successfully Netezza with Greenplum. In this case, we actually did what we call latency. We have all the customer gateways where the trade traffic comes through or the order traffic comes through. We actually have hardware that basically puts a timestamp on every message. And now those messages get sent over to a Greenplum environment where they get trickle loaded every 5 minutes. That information is required for us to do that capacity planning and kind of proactive alert notification when we hit certain throughput thresholds. And it's very complex because the amount of volume that we have to deal with is incredible. But some of the data is not all in Greenplum, and this is the Greenplum latency system. A lot of the data in terms of the transactional and the historical stuff is sitting in Netezza. So in some cases, we need to basically join some of that information and union some of that information. And that was that use case example. Another example is just trying out traditional databases. We have a lot of applications that are being developed that kind of use MySQL as a cache store. And it's possible that we need to integrate some of those cache data with Oracle, which is our traditional relational database technology. Files and database technologies integrated. Netezza with XML, and Netezza with Netezza, which is the case of the vertical partitioning that I mentioned earlier. So a lot of different flavors, and we want to prove out is that we can actually support heterogeneous environment in that different types of data sources and different types of databases using different drivers. The common business vocabulary and being metadata driven is obviously important to ROI. It's important to being agile. So that way we can empower the business. It's just too long every time you have to sort of knowledge transfer from the business community to the business analyst to the developer and so forth and so forth. So we're sort of moving more quickly towards these types of tools. And this was very immature, premature, but now they're becoming a lot more mature, so we're seeing a lot of value. And we're trying to build sort of a portfolio around these technologies that can allow for that. For example, ETL, where you were in an ab initio shop, we have custom ETL solutions, grid-enabled ETL solutions, but we're moving towards a metadata-oriented type of ETL solution. User access. I mentioned that earlier. It's important for us to sort of know and see what people are doing, because a lot of times from a data architecture perspective, people say this is really important, it's very relevant, but realize that the number of hits or the percentage of usage for particular data points or how they use it is not really valid. So we want to validate in terms of what's really going on. We want to basically be able to go back and look at the information and say, you know what, these objects, these columns, these relationships are really being utilized very frequently, and we can basically evolve and tune our data architecture, our distributed data architecture. And that's part of the statistics, and then centralized logging, so we can better troubleshoot our systems. These are just some of the composite, things that we looked at and, obviously tested. procedures. An example of procedures I mentioned about how our ARCA data is encoded. We basically wrote a function that exposed all those bits as a series of fields, and now users can very simply write a filter, give me this and this or that, and it made it much easier. Now you can add BI tool on top of that, where before it's not possible for us to sort of move forward with that kind of strategy. Administration capabilities, at the bottom over there, certainly we've tested, and even in a 4 to 6 week period, we actually were able to test simple pass-through query tool, Aqua Studio, which you can now have to purchase, but very good pass-through SQL tool. Deployed a connector to a bunch of users that had no knowledge of Composite, but now we showed them one kind of Composite view, and we were able to run their particular queries, if you will. The Aqua Studio sees the Composite repository as a database and columns and objects and columns, so it looks like real metadata coming back from a database, which is very valuable. Business objects, we've integrated OBI, which is the Oracle Business Intelligence Enterprise reporting tool, and then we have our own internally developed Java-based query tool, and we successfully integrated, and the goal really was to show that we can integrate all these various flavors of tools with different patterns of access using the same connectors. And then some CIS features, the Composite Integration Server. The ability to throttle is key to us because we're dealing with huge volumes, and to manage CPU efficiently is key. The queuing aspects are key. Putting intelligence in terms of how it does connection pooling is very important. How it does, the join, whether it's hash, sort, semi-join, all that's very critical because we're dealing with such heavy-duty data. And those are just some key points in the intelligent query engine evaluation that we pointed out. Ability to push down, because we are heavily invested in MPP systems, and we want, where it makes sense, to push some of that work down to the database. We've already invested the money there. And then in other cases, do it in the middle tier. And data streaming is something that we're going to keep building on. A lot of our ETL capabilities are all based on data streaming and single pass type of processing. And there are really two main paradigms of access that we focus on at the highest level, which is either web services oriented or relational oriented. And that's how sort of we start from the top. And security, obviously we want to move towards LDAP, but it's a good sort of alternative if you have a middle tier that can provide you some of that sort of centralized metadata management around security and entitlement. And just a picture of the tools, and I mentioned from a productivity perspective, these tools are intuitive, they're pretty straightforward to use. We were able to leverage them very quickly. 3 to 4 man team, we were able to sort of build out the first 2 systems that we deployed. Our special report that we create for SEC called the -5, and the latency capacity planning type of stuff. So our biggest barrier, from an RI perspective, is really our technical challenges around the size and complexity of change in our environment. So that was key for us to choose the technologies, the combination of technologies and how they integrate. The architecture basically that had to deal with the mergers, the compliance need of large windows of data and huge, looking for a needle in a haystack type of problem, and being able to support multiple lines of businesses using a shared data services environment. What we expect from an ROI and benefit perspective is we want to leverage existing IT investments, so we've got a bunch of things already built. We just want to formalize the integration and standards around them. We want to take advantage of the current data skill sets that come in. Obviously, when we acquired NYSE Life, some smart people came with that. They understand their business processes. We don't want to take over that function, but we want to basically standardize and integrate with those folks. We want to come up with sort of a reference architecture, a governance on top of that, and sort of have a kind of a PMO office that manages projects from a virtual perspective, but leave each lead, architecture lead, and each development team to do their thing, but more sort of in line with the strategy. And quick reaction to business needs. Yes, we have to do things tactically, but at the same time, in parallel, we want to basically start utilizing and evolving these all these different patterns and architectures and software that I spoke about. And fast time, obviously, to the solution. So we want to choose solutions where, we're not going to try it for a year. We don't have the tolerance to do that. We want to make sure it's mature enough and we can quickly handle some of these complex use cases, from day 2.